All right, we're going to do some examples of problems that involve possible lengths of the sides of a triangle. First of all, whether or not 3 lengths could be a triangle or not. And then, given 2 sides, finding possible lengths for the 3rd side. So for the first type of problem, and actually both of these are going to use a particular principle where 2 sides, the sum of 2 sides of a triangle need to be greater than the 3rd side. So we have to be able to take any 2 sides, add them together, and it's got to be more than the other side, which wasn't included in the sum. So for a problem determining whether 3 lengths can make a triangle, you just be given 3 lengths, 2, 3, and 4. Basically what you can do is add up every combination of 2 sides. So we can go 2 plus 3, which is 5. Is that greater than 4? Yeah, it is, right? Okay, so that works. 3 plus 4 is 7, which is, of course, greater than 2, right? And the only combination left is 2 plus 4, which is 6, which is, of course, greater than 3. So that works. All 3 different combinations of sides, right? We can add them together, and we always get bigger than the other one, which wasn't added together. Okay. Now, if you're thinking strategically about these, right? If you take the biggest side and add it to any of the other sides, it's got to be that's always got to be bigger because the first one is bigger to begin with. So the real question is whether the 2 short sides add together to be bigger than the long one. So you can do these problems in one step. For example, if you get something like 7, 9, and let's see, 17, right? The 2 short sides are 7 and 9, right? 7 plus 9, 16, which is not greater than 17, right? Do a couple more examples. 2, 2, and 3. That works because 2 plus 2 is bigger than 3, right? Those make 4. Okay. How about 2, 2, and 9? Right? That doesn't work because 4 is not bigger than 9. How about 2, 3, and 5? Okay, this one's kind of tricky because 2 plus 3 equals 5, right? Is that bigger than 5? Answer is no. Therefore, this does not work, right? So these ones don't work. This one does. These ones don't. This one does. Okay, as a recap. Okay, so there's a few examples. All right, next type of problem is finding possible lengths for the 3rd side of a triangle. Okay, usually we call this side S. Okay, you can call it whatever you want, but or sometimes you'll be given the name of the triangle, like ABC or something, and you might be looking for side AB or something like that. But usually you're just given 2 numbers, like 4 and 7, right? Okay, well here's what we know. The sides are 4, 7, and S, right? We know that 4 plus 7 has got to be bigger than S, okay? We know that 4 plus S has got to be bigger than 7, and we know that 7 plus S has got to be bigger than 4, right? Now this one's no problem, this last one, right? Because 7's bigger than 4 by itself. And we can't have a negative number. So as long as we remember that it has to be bigger than 0 no matter what, then this one we don't need to worry about, right? Because 7's bigger than 4 as it is. So what we can do is take these and solve for S. So I'll take that first one. 4 plus 7 is greater than S. Okay? And if it's already solved for S, right? I just add 4 and 7. So I get 11 has to be greater than S. Okay? Now, the other one, I have 4 plus S is greater than 7. So I can subtract 4 from both sides, and I get S has to be greater than 7 minus 4. Right? Which is, of course, 3. So S has to be bigger than 3. Now, all 3 of these things have to be true at once. Right? So that means, since this one's going to be automatically true, that means these both have to be true. So if you write 2 inequalities like this, you have to say and. Right? You have to use the word and. An easy way to take care of that without having to write the word and is just S has to be, let's see, bigger than 3 and less than 11. Okay? And that's one statement that answers the whole question. Now you'll notice what we've done here. We took the two sides we knew, added them together, and subtracted them. You can pretty much always do that. You're always given two sides, right? In this case it was 4, right? So that didn't really look like a 4. 4 and 7, we take those two and add them together. So if you're given like 18 and 9, right? S would have to be bigger than 18 minus 9, which is 9, and 18 plus 9, which is 27, right? And you're done, okay? But if you need to, if you can't really remember exactly what that pattern is, you can remember this principle that any two sides had to be bigger than the third one, and you can use that to find the answers. Okay? All right, and there you go.